Hi there, this video is about the travel cost method in which we will focus on the zonal travel cost method. It is one of the ways to evaluate the benefits of a certain recreational place, and how we can do this we will learn in this video. This is the acronym TCM, and it is usually used for the value of the recreational sites in the opinion of the people. Basically, we are considering a market where the uh, visitors, they are geographically spread, and they are coming from different origins, and they have different travel costs, because as they are traveling from different levels of distance, the travel cost will be different. So let us see that how this travel cost can be used to find out the value of the certain recreational place. There are different total costs, as we already understood, and they will give rise to different rates of visits. The lower the travel cost, the more are the visits. And that basically gives us the basis for estimating a demand curve, because this is quantity and this is the price that people pay to travel. So in this process, we will have the travel cost and visits, which will allow us to find out the inverse demand function, from which we can calculate the consumer surplus for individuals and for zones. And we will also add the admission fee if it is there, that is the entry fee to the recreational site, and that will give us the value of that recreational spot. So we are focusing on the zonal travel cost, which is defined by various zones. Here in this case, we are considering that there are 5 recreation zones that can be used to see that how different people travel from various zones to the recreational spot. And in this zonal travel cost method, we use the data from the actual visitors rather than potential ones. This is good in the sense that we are going to interview the people or collect the data from those who are actually visiting the place, rather than those who are willing or may not be willing or partially willing to visit the place. So this is more reliable when it comes to actual visitors. Now these zones can be in various shapes. 2 possibilities are highlighted here: concentric circles and iso timelines. This is an example of the concentric circle situation, where this is the recreational area, this is zone A, zone B, zone C, D, E. So the 5 zones, they have been highlighted. This is the closest, so more people are likely to come from here, and this is the farthest, and lesser people are likely to come from here to the recreational area. The ISO timelines, they can be understood with this highway. A is the closest to the recreational area, B is farther, and then E is the farthest area or the zone from where the people will travel. Definitely it is more costly to travel from area zone E as compared to zone A. So this is how it works. The distance decreases from the zone A to E. Now this is the table that will help us to understand the whole calculation for the travel cost method. So this is the table in which the zones have been listed: A, B, C, D, E, the 5 zones. They have their own population, and the first thing that we have here in the third column, which is in hours, is the one-way travel time. A is the closest to the recreational site, so it takes least amount of time, and E is the farthest, so it takes the highest level of time. Since it's a two-way travel, one has to go to the recreational point and then have to come back. So we multiply this time with 2 and it becomes this. Now the opportunity cost is also given. It means that if people are traveling to the recreational spot, they are definitely letting go something, and that foregone opportunity has to be included in terms of dollars. Can be their time or hourly wage. So this is that amount that we have. Definitely people from different areas would have their own level of wages and occupations, and definitely their wage would be different. Now the persons that are in the vehicles, we assume that from zone A only one person, and also from the zone B only one person travels, whereas from C and D and E two people are traveling. This can change if the number of people is changing. Now the total opportunity cost will be the product of the two, that is these two columns will give us these two columns, and this column, because this is the two-way travel time. Here the one was there, so it didn't make any difference. Here we have the opportunity cost. This is the total hours spent in traveling, and this is the number of the people in the vehicle. So now these three columns will give us the final answer. Here again, the two-way travel time, per hour opportunity cost, and the number of people in the vehicle. So this is basically for all passengers. We are including all the passengers in a vehicle. The next thing is the first one-way travel distance. This was the travel time. This is now the travel distance. This is the closest, so it has the shortest distance. E is the most distant zone, so it has the highest distance. And the two-way travel distance will be the twice of it. So now we have calculated the twice. 90 will become 180 and 150 will become 300. So the operating cost is also given. This is the fuel cost that is required. It can also include the other costs like maintenance costs, etc. So the operating cost of traveling, the mechanical aspects, the fuel aspects, it is also given per kilometer. We have $0.15. So this should be multiplied, and once we do this, you can see that we have done this as we go ahead. This is for various regions, and it is also increasing as we go from region A to region E, because the greater the distance, the greater will be the value of the operating costs. You can also see the calculation, that is 4 into 0.15, because 4 is the kilometer distance, two-way travel, and per kilometer operating cost is here. So if we multiply these, we will get the total operating cost for two-way travel with this distance, that is 4. So 300 into 0.15 will give us 45. So all these values basically are showing the various operating costs, and this is for the same vehicle. Now we come down to the people again, the passengers. We already know that they are 1, 1, 2, 2, 2, as we already listed them before. Now the average total cost per person will be calculated. So the average total cost per person is simply the sum of the two costs, that is the opportunity cost and the operating cost, and then we will divide it with the number of persons in a vehicle. So here we are. This is the first value for zone A, the travel opportunity cost that we calculated. Added the operating cost for the zone A, which will be 10.4 divided by the persons, that is 1. So it will become 10.4. It will remain the same. Again 11 plus 9 divided by 1 will be 20. Here 96 plus 42 divided by 2 will be 69, and 112 plus 45 divided by 2 will be 79. So in this way we can calculate the average by dividing by the number of persons, the sum of the travel opportunity cost and the operating cost. So opportunity cost and the pocket out of cost out of the pocket will be considered. Now these values are a per person value of the travel cost. So I can add the admission cost in it. Admission fee is $10 for each person. So 10 plus this 10 will become 20. 20 plus 10 will become 30. And 79 plus 10 will become 89. So this is the total cost per person when we have added the admission fee into the recreational spot. These are the average number of visits uh, to the closest zone. We have the highest number of visits per person, and when compared with the farthest area, that is the zone E, the average number of visits have declined to 1. So it is quite intuitive, and we can use this information to come up with the relationship between the travel cost and the average number of persons traveling to the recreational site. Here we have found the regression line by using the travel cost and the number of trips, and you can see that we have used this simple regression process. Intercept is found, which is 93.74, and the slope is also found, which is 4.9. So when we use this, we can put the travel cost value. We can get these values by putting the various values of visits. If the visits are 0, it means that the total cost is the highest, and if the visits are 10, then the travel cost is the least. So this makes sense, and it is quite synonymous to an inverse demand function, as you can see in the diagram as well. Now you see that there is the calculation of the consumer surplus, which is 553 here, and this status basically will allow us to focus on the graph, and you can see we have visits per person and travel cost per visit on the y-axis. And if you consider the zone C, it is here. This is zone E and D, A and B, the same demand curve that we understood, the inverse demand function. This was the equation that we developed by using the regression. There should be V over here, 4.90 V. Apology for this typographic omission. Then we have consumer surplus for people from zone C, and that will be 87. This is basically the height of this triangle and the base multiplied and then divide by 2. So we can come here and see that how this is done. For zone C it is 87, as we saw there, and for zone A it is 553, because for zone A it will be this base and this much of the perpendicular. So it's a very large triangle, and its area will be greater since the cost of travel is less. So as we go down to area zone E, it is having least volume of the consumer surplus because it is having a high level of traveling cost here. It's a high level of travel cost, so the consumer surplus is simply this triangle. Now we have calculated the consumer surplus per person. Now we can translate it into the consumer surplus per zone by multiplying this with the population of that zone, and definitely all the consumer surpluses with their respective populations, and we will get these values, right? And after doing this, we can find the trips per zone. This is also easy, that we can multiply this value, the average number of visits per person, with the population of the zone, and we will get the trips per zone. This is also trips per zone, one average number of visits per person, and there is 10,000 people, so it becomes 10,000 trips per zone. Finally, if we add the admission fee into this calculation, it will be a multiplication with 10, because 10 is the admission fee and this much of the trips are happening. So the number of trips multiplied by the admission fee for one trip, one entry, will be equal to this. So you see 10 is being multiplied with all of these values, giving rise to this value. So the admission fee here is calculated, and here the consumer surplus was calculated, and we can see that this is also in dollar terms. So this is the admission fee that they are willing to pay, this is the consumer surplus that they are able to gain So therefore, we can also write this in millions because it's a long value. So $11.65 million, and this is $4.4 million. If we combine these two values, basically it's going to give us the total travel cost, because this is the amount that they are spending from out of their pocket. So this shows their willingness to pay. But we should also consider this because this is also being paid as the um, admission fee. So we also include this component. Here we are in millions, we have found the answer. So you see that it is $16.51 million. And if something else is to be done in this recreational spot, for example, logging or any other activity, then the returns from that alternative should be greater than 16.51 million. Otherwise, there will be overall loss. So this is how we can calculate the traveling cost for a recreation site. Now we come to the limitations. This method has a few limitations. WTP is basically found for the overall recreational site, but recreational site has various features. For example, the hiking trail, how interesting it is, how lengthy it is, how exciting it is to have a hike on that trail. There can be other features of any recreational site. So if the WTP is found for various features, then we can have a more specialized analysis, because some people will be interested in hiking and some people will be interested in looking at the trees or anything else over there. So that will give rise to another version of the travel cost method, which will be known as hedonic travel cost method, because we will be considering the hedons or various features of that recreational site. And the omission of the capital goods cost, it's also common, because when the people travel, they take quite a bit of luggage with them. For example, tents and the sleeping bags and wet weather gear, etc. All those things, they are also taken to that place. So the cost that is incurred in buying those goods or maintaining those capital goods should also be included in the travel cost method, which was not included in our current example. There are multi-purpose visits. People, they can go to recreational site, but if there is something else nearby, for example, a river, they can also go there for fishing or any other activity for recreation. And when this happens, the WTP is getting overlapped with the other objectives, because they're not there only for the recreational site, they're also there for some other place which is nearing the recreational site under consideration. A similar situation can arise when people are fond of traveling, because when they are fond of traveling, the recreational site will not be the only objective of traveling. The journey itself will also be another excitement for the people, and they'll be willing to pay for it. This is why the overall WTP will not only be for the recreational site, it will also be for the journey that they do from their home to the recreational site and then back. So this way we get the site benefits overestimated, because the WTP of the journey itself is also included, and that's why the calculated recreational site benefits, or WTP, is overestimated. And we can also consider the fact that the truncated dependent variables, they are involved, because the actual visitors are surveyed, not the potential visitors, which means that if we apply OLS on the truncated sample, where the actual visitors are surveyed only and the potential visitors are omitted, then we will get biased coefficients, that is the slope coefficients. So this is another problem. The solution for that is simply to use some advanced tool for estimation that will cover the problems caused by the truncated sample. And finally, the omitted variable bias can arise because the price of the substitute recreational sites varies across the zones, because there are other recreational sites and they will be different for different zones, their prices. And in addition to that, people have different tastes for recreation. They might like one or the other recreational site due to its features, and primarily due to their taste for those features. So this is why we have to control the other factors like tastes or the price of the substitutes, and if we incorporate them or and in control for them, then the omitted variable bias will be overcome. Otherwise, this will cause imprecision in our regression, which is used in the travel cost method. So these were a few limitations that can cause imprecision in our estimations. This was the calculation of the consumer surplus. This was the estimation of the inverse demand function, the tabulation, and this was the final result of the travel cost method, which is based upon this table, which is a comprehensive table listing each and every value and how the calculations are done. And this is one of the possibilities of these geographical distribution of various zones, ISO timelines, and the concentric circles. We were focusing on the zonal travel cost method, where we divided various segments into zones, and this was the whole process in this flow chart. This is the base for the regression, the relationship, the inverse demand function, and this was the basic idea of the travel cost method, that is the zonal travel cost method. Thank you.